Hi, in this video I'm going to solve one problem on composition of functions. So for composition of functions, we know that we have to compose functions when we have the symbol circle for two functions. Now take note, this is different to the dot symbol because a dot symbol means to multiply. A circle, on the other hand, is or symbolizes that we have to do composition of functions. And I will show you how to find a certain composition of function. It could be f circle g of x or g circle f of x given two functions. Let us first find what is f circle g of x. The meaning of f circle g of x is f of g of x. So what does it mean? It means we are going to place the g of x in the place of x in the f of x. Meaning to say, if f of x is equal to x plus 1 and g of x is equal to 2 over x plus 3, we will be replacing this x, so this x in the f of x, with the g of x. Okay, so we are putting the g of x inside the f. So this g that we have, which is 2 over x plus 3, will go to the x of f of x. And the result will be, if we place it inside, so it means f of g of x, the x becomes 2 over x plus 3, and we have to still copy the plus 1. After that, we have to simplify the expression. To simplify 2 over x plus 3 plus 1, we have to combine them as a single fraction. So how can we easily combine this? Now, when working with fractions, normally we have a fraction plus another fraction. But for a whole number like 1, we can think of 1 or rewrite 1 as x plus 3 over x plus 3. Because x plus 3 divided by itself is 1. Where are we getting this x plus 3 idea? It's because we want to have the denominator x plus 3 for 1 as well. Now other works or other solutions could be working with the LCD, and that is just a similar idea. Okay, but instead, a quicker, at least for me, a faster way is to think of 1 as an expression of x plus 3 over x plus 3. So what will happen with our 2 over x plus 3 plus 1? Note 1 is now x plus 3 over x plus 3. So when we add fractions, the rule is when they have the same denominator, we copy the denominator and we just add the numerators. So we have 2 plus x plus 3. And this will be 2 plus x plus 3 over x plus 3, which will become x plus 5 over x plus 3. This means this is our f of g of x, which is also written as f circle g of x. Now what about the g circle f of x? Now do not assume that g circle f of x is automatically the same as f circle g of x. So this is not always true, but in some cases they can be the same, but not all the time. So we follow the same idea in finding the g circle f of x. We should know that the meaning of this is that f will go inside. So I'm using the word inside. So you place the f of x in the g. Okay, so the meaning of g circle f of x is f of x goes to g. So you work from right to left. F goes to g. So when f goes to g, it means the expression of f of x, this is our f of x, will go to the x of the g of x. And the result will be, so the g of f of x will be, so copy the format of the g, but the x of the g will become the f of x, or will become the expression for f of x. So x plus 1, and then you have the plus 3. And then you simplify 2 over x plus 1 plus 3, and this is equal to 2 over x plus 1 plus 3 is x plus 4. And as you can see, this is different to the one we obtained for the f circle g. So this is g circle f of x. Okay, So to summarize the idea of composition of functions, you always take note what function goes to another function, and always take it from right to left. So here we have f going to the g. If we have f circle g, the g is going to the f, meaning to say you substitute the g to the x of f. Here, you substitute the f of x to the x of g. So I hope with these two examples, you are now confident on how to find composition of functions such as that of f circle g or g circle f or whatever letter is used for the different functions. So keep in mind the main idea, what goes to the other function. Okay, so it's all about substituting the expression of the given function to the other function for its x. Okay, so that's all for this video. Thank you.